Hi, let's try and calculate the kinetic and potential energies involved in simple harmonic motion in terms of displacement. We know from one of the previous videos that the velocity equation is given by plus or minus omega a square minus x square, where a is the amplitude, x is the displacement, and omega is the angular frequency for a simple harmonic motion. Now we also know that kinetic energy is 1 by 2 mass velocity square, half mv square. So using these two equations, we can rewrite kinetic energy as half m. V is plus or minus omega square root a square minus x square. When we square that, we get omega square times a square minus x square. Let's call this equation 1. Now we also know that total energy in the system is sum of potential energy and kinetic energy, which means when potential energy is 0, kinetic energy is max. So if we know the maximum value of kinetic energy, then that becomes total energy. So the maximum value of kinetic energy, if we can figure out when potential energy is 0, that becomes equal to total energy. From equation 1, we know that the total energy or the maximum kinetic energy, the max kinetic energy, which is nothing but total energy, can be obtained when this is 0. When the displacement is 0, this value maxes out. So it becomes 1 by 2 m omega square a square. Let's call this equation 2. So we have the total energy, we have the kinetic energy. So the potential energy is total energy minus the kinetic energy. The total energy is half m omega square a square. The kinetic energy from equation 1 is half m omega square a square. I'm just expanding that, plus half m omega square x square. These two terms cancel out and we get potential energy PES half m omega square x square. This is equation 3. So from equation 1, 2 and 3, we can find the energy, kinetic energy, total energy or potential energy of the system in terms of displacement. Thank you.